Okay, this video is going to teach you about slope-intercept form. A slope-intercept form is just like function form. You need to solve for y, just like you did for function form, and then ensure that the terms are in the following format, and that is y is equal to mx plus b, where y and x are both variables. M is your slope of the line, and b is your y-intercept. Now, you want to make sure that it's addition. So here, this should be addition. And you'll see why on the next page. Okay? So let's try and find the slope and the intercept from equations. Here I have two equations, and I want you to find the slope and the y-intercept. Well, the first one, it really is in slope-intercept form, except for that minus. What we're going to do is we're going to say this is equal to y is equal to x plus negative 4. Now, if you're trying to identify the slope, there's no number written in front of that x, but remember that's the same thing as having a 1 in front because you have 1x there. So the slope is 1. The y-intercept then is negative 4. It's just this number on the end. This other one over here, you actually have to solve for y to find the slope and the intercept. So I'd like you to write this down, pause the video, and solve this one yourself. Okay, subtract 3x from both sides because, again, we want it to be y is equal to mx plus b, so we're going to leave the y on the left side here because it's right here, see? All right. Now, the 3x goes away on the left, and you have 5y left over. And then these are not like terms, 10 and negative 3x, so we're going to write them separately. And we're going to put the negative 3x first, because we want it to be in y equals mx plus b. And then we'll write plus 10, because it's a positive 10. I'm going to subtract, I'm going to divide 5 by every term here to get rid of the 5 that's with the y, and y then is equal to, now how could we rewrite this fraction? Remember that we don't want the variable up there, so what we could do is we could take it like this, because that means the same thing, and then plus 10 divided by 5 is 2. So our slope, m, is equal to a negative 3/5, and our y-intercept is a positive 2. Cool, huh? Let's move on. Okay, now I want you to graph an equation that is in slope-intercept form. First of all, I want you to realize this here. This is actually negative 2/3 x. Okay, that's just the only way I could write it with the computer. Now, for the slope, first of all, what you would do is you say, all right, well, I know that this is my y-intercept. So if I went on the y-axis to 4, there is a point that's on this line. Then what I do is I take the slope to graph the rest of the line. Now the slope can be like this, with a negative on top, or it can have the negative on the bottom. This one here means move down, because this is a negative direction, this is a positive direction, this is a negative direction, this is a positive direction. So this means down 2, and then right 3. Because down, because the negative is on the 2, and then the right would be positive. The negative only applies to either the numerator or the denominator, but not both. This one here, top is positive, so that says go up 2, and the negative is on the 3, so you would go left 3, which is the negative direction. Let me show you that they both work. So if I started with this point here, that's at y is equal to 4, and I use this first slope. That says move down and go to the right 3. So from here, I'm going to go down 2 to the right 3. Make a point. Down 2 to the right 3. Make a point. Down 2 to the right 3. Make a point. See how all of these are lining up? And that's the way it's going to work. Now, you could also use this other one over here, which says move up 2 and to the left 3. So if I were at this point, I can move up 2 and to the left 3, and it still lines up. Up 2 and to the left 3. You see that all of those points line up? Which one you use, the down and right or the up and left, really depends on your graph. If you're starting with an intercept up here, you don't want to use something that goes up and to the right because you'll be off your graph. You want to start with something that would go down to the left. Okay? So it just depends on what you're given. Then what you'll do is you connect your dots, stoop, arrows, and all is good. Pretty cool, huh? Yeah, I like that stuff. Now, if you looked at the equation from before, y equals negative 2/3 x plus 4, you would have noticed right away that the slope is negative. And remember my skiing story. Slope is negative when I was going downhill skiing. Remember? That's when I was freaking out. Wah! If you don't remember that, then watch that video. But looking at this right here, the negative, you knew right away that the line was going to go down from left to right because it was negative. And sure enough, it does. All right. Let's do something else. Here I have two equations where the lines are going to be parallel. The lines are parallel if they have the exact same slope. So stop the video. I want you to solve these equations for y, put them in slope-intercept form, and then try graphing them, okay? Go ahead and do that real quick. Okay, for this first one, you divide by 3 on all terms, and y is equal to a negative 4/3 x minus 2. Now that's the same thing as plus a negative 2, so let me write it that way, plus a negative 2. So in other words, this line is going to go through negative 2, and I am going to go up on this one. So I'm going to go up 4, left 3, up 4, left 3, up 4, and left 3, and there is my first line. Okay? The next one, I'm going to start by subtracting 4x from both sides. And I have 3y is equal to negative 4x plus a negative 18. Again, they're not like terms, that's why I have them separate. Then I'm going to divide each term by 3. X is equal to a negative 4/3 x, and then plus a negative 6. Notice that both of these have the exact same slope, which means that the lines should be parallel. So I'm going to graph this second one. It has a y-intercept of negative 6, it's way down here, but the slope is the same. Up 4, left 3, so up 4, left 3, up 4, left 3, up 4, left 3. And when you look at it and you graph it, sure enough, they are parallel lines. Okay? So if they have the same slope, they're parallel lines. Now, perpendicular lines have a slope that are negative reciprocals of one another. This is the one that most students have trouble remembering because same slope is easy to remember. Negative reciprocals are like, something about that whole terminology confuses them. So here, let's solve first for y. So we put it in slope-intercept form. First thing we do is subtract 3x from both sides. And we have 2y is equal to a negative 3x plus 16. Divide every term by 2. Y is equal to a negative 3/2x. And this is plus 8. So I go up to 8 and make a point. And then that means I'm going to use down 3 and right 2. Down 3, right 2. Down 3, right 2. Down 3, right 2. And now if any of you are confused about why it's down and on top, because remember this, change in y over change in x. The slope, our top value is always going to be the y. It's always going to be your up and down. And x value is always going to be your left and right, just in case you forgot that. Now, think about negative reciprocals. So this line right here has a slope. M is equal to negative 3 over 2. So first of all, what is a reciprocal? Hopefully you're saying, well, it's a fraction flipped. So 2 over 3. Great. Now, a negative reciprocal, meaning this thing originally is here, negative 3 over 2. What I'm saying is the new one has to be a negative reciprocal of it. So negative 2/3. Double negative means this would be a positive 2/3. Because it's the negative reciprocal. You can think of it as just the opposite sign. Okay, that's one way you can think of it. Flip the fraction, take the opposite sign. So, if we solve this one, for y, you divide by 3, all terms, and y is equal to 2/3 x minus 2. And look, that is exactly what we expected it to be. So we go to negative 2, plot a point, and then we're going to go up 2 to the right 3 because it's positive, so we expect it to go up from left to right. Up 2, right 3, up 2, right 3, up 2, right 3. If we graph this, you see that it is perpendicular to the other line. Okay? That's all, my friends. Goodbye now.